This question here, right, we're told that the system is in equilibrium, okay? In other words, all the forces combined balance, so there's no net movement. So there's a force pulling that way, this way, and this way. The overall effect is it doesn't move, right? So it's all balanced. So the first job we need to do, okay, to use that fact in order to work out P and Q, is to resolve these forces, okay, in along the x and y axes, okay? So we're going to do a cross here. And it's obviously there's going to be 8 there, and we're going to have 12 there. That they are going in those x and y directions. The Q, okay, well, because the angle is 30, the adjacent here, so it's going to be Q cos 30 along the x-axis and Q sine 30 along the y-axis. P then, well, it'll be P cos 45 then, and P sine 45 Q, okay. Now, because the system is in equilibrium, okay, well then we can say, when we resolve along the x-axis, okay, well, we can say that 8 plus Q cos 30 is equal to P cos 45. They're going to balance, right? They've got to balance out. What's going right has got to equal what's going left. They've got to equal because there's no movement. They're balancing out there. What I do then is, I'd work this out, okay, so we know Q is, we know cos 30 is root 3 over 2. We know cos 45 is root 2 over 2. Okay, so that's quite nice. We could tidy that up again then, maybe, if I times through by 2, I think, yeah, times through by 2, that becomes 16. Now, the good thing is then they cancel, won't they? So I'll get root 3Q equals to root 2P. Okay, so that's quite nice there, equation 1. Now when I resolve then in the y direction, I'll have P sine 45 plus Q sine 30. That will equal to 12, yeah? So what's going positive y, it's got to equal what's going negative y. Again, P sine 45, well, sine 45 is root 2 over 2. Sine 30 is a half, and we've got 12 there. Again, look, I'm thinking, let's times through by 2, okay? Because that will cancel, that will go, won't it? So I'll have root 2p plus q equals, and obviously I'm going to times that by 2, 24. Okay, equation 2. Now, what I hope you notice here with equation 1 and 2, they look kind of complicated with all these roots in, but if you notice here with number 1, we've got an expression for root 2p. It's equal to that, 16 plus root 3q. But notice then I've got root 2p in here. So what I could do, I could substitute my expression for 1 into 2. So I'll say that. So sub 1 into 2. So what I mean is, if we look at 2 now, right? Well, I got root 2p here. Well, I don't have to write it as root 2p. I could write down what root 2p is actually equal to in 1. So say 16 plus root 3q plus then q here. And that equals to 24, okay? So I'm replacing the root 2p with what I got for 1. Now, take the 16 over the other side, yeah? So 24 take away 16. And here then, I got root 3q plus q. Well, I can factorize out the q there, can't I? And then obviously that'll be root 3 plus then, well, 1, isn't it? To get my q. And then to get q then, well, 24 take away 16 is 8. And because I've got root 3 plus 1 in a bracket, and you timesing, and you take it over and you divide. So I've got my q then out to be that. So if I do that then, 8 over root 3 plus 1, and my answer comes out to be 2.928. Now they wanted to certain amount of decimal places. They wanted a 1 decimal place, so it'll be 2.9 newtons. Okay. All I've got to do then is sub this answer into well, you can put it into 1 if you want to work out what p is. So sub in 1, okay, so 16 plus root 3 times q, which basically would be my answer, won't it? So on my calculator, I'm going to put answer in, equals to root 2p, yeah? Okay, so then p will equal to 16 plus root 3 times 2.9 divided by root 2. So on my calculator, if I type that in, 16 plus, I'll do the fraction button, 16 plus root 3, if I times it by ants there, and then over root 2, so I get my answer then to be, let's press the SD button, comes out to be 14.9 newtons. Okay, so I've got my two answers there to two decimal places. And we can clearly that. Okay.